Yeah, I know. So you tell him he messes with Chuck Norris, he messes with me. All right, I gotta call you back. Bye.
Oh, is this thing on?
Oh, hey, Algebra 2. Today we're going to be going over the worksheet that I handed out. It should be Tuesday by now if things go as planned. It's titled Hacking Higher Roots to Pieces. It's basically doing prime factorization on roots higher than, things higher than square root, cube roots and fourth roots and so forth. So let's dive in. Number 1.
Make sure that's showing up there. There we go.
Okay, we have the third root of negative 135. Now, with any kind of root that's higher than 2, that's an odd root, if we have a negative inside the root, this is the same as the cube root of negative 1 times 135. And the cube root of negative 1, well, negative 1 times negative 1 times negative 1 gives you negative 1 back. So this negative 1 can just come right out. So this is going to be equal to negative 1 times the cube root of 135. So negatives, they just come right out on an odd root. Now on an even root, if we have a square root or a fourth root, then we're going to get into imaginary numbers, and we'll talk about that later on in this course. But for now, you won't see any on this worksheet. But if you have an odd root here, the negative can just come right out. So negative 1. Okay, the first thing I'm seeing here, okay, 135, we're ending in 5 or 0. So I'm going to start by dividing that by 5 and seeing what happens. Looks like that ends up being 27. So it's negative 1 times the cube root, sorry, of 27 times 5. And let's see, we can break this down a little bit further, right? This is going to be 9 times 3 times 5. And then this can break down into 3 times 3, right? So we've got all these that we're working with here. Now, with a square root, we want to find pairs, but with a cube root, we want to find perfect cubes that we can bring out. So 3 times 3 times 3, well, that's going to be a perfect cube. So that can just come out to the front as a 3. So it's going to equal negative 1 times this 3 times the cube root of 5. Okay? Otherwise known as negative 3 times the cube root of 5. And there's our final answer there. Number 2.
Slide that up.
Okay. We have the cube root of 216. Now, with these, it's good to think in terms of perfect. If we know our perfect squares, you've got 4, 9, 16, 25, and so forth. It's good to kind of have in mind the first couple of perfect cubes as well. 2 cubed is going to be 8, and then 3 cubed is going to be 27, as we see here. This looks like a good candidate to divide by 8, and that would be great if we could. So let's see if that divides by 8. 216 divided by 8. Sure enough, that's going to be the cube root of 8 times 27. And we just said that 2 cubed is 8. That turns into 2 times 2 times 2. And then 27 actually turns into, well, 9 times 3, and 9 is 3 times 3, so it turns into 3 times 3 times 3. 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. So it looks like we have 2 perfect cubes here. We have a 2 cubed and a 3 cubed. So those can both come out. So it'd be 2 times 3. Well, and then we just have, well, the cube root of 1 is just 1. So the answer to this is just going to be 2 times 3, or 6. So yeah, as it turns out, 6 cubed is 216. All right, number 3. We have the fourth root of 32. Now, you're not going to get to the point where you can memorize fourth roots very easily, but this looks like we can divide it by 2 several times, right? So let's just kind of break that down. 32 is the same as 16 times 2, and 16 is the same as 8 times 2. Then 8 is the same as 2 times 2 times 2, right? And we're looking, since we're doing the fourth root, we're looking for groups of 4 here. If we have a number that's repeated 4 times, we can bring it out in front. So we have 1, 2, 3, 4 2s here. So those can all go outside of the root, and then we have this lone 2 left. So this is all going to break down to 2 times the fourth root of 2. All right.
This one here, good.
Number 4. We have the fourth root of 405. And like I said, I don't really know, I don't really have fourth roots memorized, and you don't need to either. Let's just see if we can break this down. Looks like this is divisible by 5, so let's start there and see what happens. So 405 divided by 5 ends up being 81 times 5. So 81 times 5. Now this is interesting. 81 is 9 times 9, and 9 is a perfect square. That ends up being 3 times 3 times 3 times 3, and we have this lone 5 that's going to stay inside the radical. Since we're dealing with the fourth root, we're looking for groups of 4, and sure enough we have one here. This group of 4 can come out as a lone 3, so that equals 3 times the fourth root of 5. And we're done. Okay, what's it? Number 5.
Let's make sure we're in view here. And we are.
We have 5 times the fourth root of 80. Okay, let's see if we can break this down a little bit more. Let's start by dividing this whole thing by, let's divide it by 8 and see what happens. So this turns into 8 times 10. 10 is 2 times 5. Those are both prime numbers, so we factored that completely. And 8, as I remember, is 2 times 2 times 2. And that's a good thing to remember. 8 is the cube root of, I'm sorry, 2 is the cube root of 8, right? So we're dealing with a fourth root, and so we're looking for groups of 4 here. We've got it. We've got 4 2s that we can work with. Those can all come outside as a single 2. And we have this lone 5 that's going to stay inside the radical. So that equals, don't forget about this 5 outside, 5 times 2 times the fourth root of 5. And of course that equals 5 times 2 is 10 times the fourth root of 5. Number 6.
Make sure that's in view there, good.
We have -2 times the fourth root of 96. All right, let's break this down. 96 divided by 2 is 48, so that's 48 times 2. 48 is 24 times 2. And then 24 is 8 times 3. So we have a prime number, prime number, prime number, and we know what 8 is. That's just going to be 2 times 2 times 2. We're dealing with a fourth root, so let's see if we can find some groups of 4. We've got 1, 2, 3, we've got 4 2s and another 2 left over. So let's bring these guys out and these guys out as a group of 4. So let's bring this -2 over times this 2 that just came out of the radical. And then we have a 3 times 2, we have a 6 inside the radical. So we're the fourth root of 6, otherwise known as -2 times 2 is -4 times the fourth root of 6. Let me scroll down here. We'll get to number 7. Okay, number 7.
Are we on view? Almost good.
Number 7. We have -5 times the fourth root. I guess they like fourth roots on this, don't they? The fourth root of 32. I think we had a fourth root of 32 earlier, didn't we? On number 3. So this should be, you can check your work there, I suppose. So let's break this down. Let's leave that 5 alone. 32 I know is 16 times 2. 16 is 8 times 2. And once again, we have our friend 8, which is 2 times 2 times 2. So we're looking for groups of 4. So 1, 2, 3, we have 4 2s here. Those can come outside the radical. So let's keep this -5. So we have -5 times this 2 comes out. And we have a lone 2 left in the radical. So the 4th root of 2. -5 times 2 is 10. So we have, I'm sorry, -5 times 2 is -10 times the 4th root of 2. Okay, we'll do number 8. I'll try and do it on the same sheet.
Hopefully I don't run out of room.
Number 8. We have the 5 times the 4th root of 32 again. Okay. Well, this is kind of lame, right? It's just going to be the negative of this. So we know it's going to be 10 times the 4th root of 2, but let's break it down just for good measure. 4th root of 32. So, of course, this breaks down to 16 times 2, and that breaks down into 8 times 2, and then that 8 we know is 2 times 2 times 2. And we're looking, since we have a 4th root, we're looking for groups of 4, and of course we have that same group of 4 we had before. So let's bring that 5 over, and then we have a 2 that's come out of the radical, and we have a lone 2 left in the radical. So 4th root of 2, 5 times 2 is 10, so we have 10 times the 4th root of 2. Okay.
Get lined up here again. How are we doing on time? 11 minutes. That's not so bad.
And we're on number 9.
That's showing up. Good.
We have 6 times the 5th root of -64 v squared. There go the u's and v's again, unfortunately. Okay, remember, if you have an odd root, the negative can just come right up to the front. So this is going to be equal to -6 times the 5th root of 64 v squared. Now, since it's v is not being taken to a power that's greater than 5, we can't do anything with that. So let's break up this 64 and see what we can do. All right, so I know that 64 is 32 times 2, and 32 is 16 times 2, and then 16 is 8 times 2.
Hopefully that's big enough. Let me see that. Yeah, it's not so bad.
And then 8 we know is 2 times 2 times 2. So since we're dealing with a 5th root, we need groups of 5. So we have 1, 2, 3, 4, 5 2s. Those all multiply together, and they can come out of the radical as just a lone 2, and then we have a lone 2 inside. So it's going to end up being -6 times this 2, which is -12, times the 5th root of 2, and then we have that v squared. Don't forget about that v squared. And there is our answer. Number 10. We have -7 times the 4th root of 486 x to the 8th. Okay, so let's see. We have an x to the 8th, and 8 is greater than 4. In fact, we could divide this into that could factor into x squared times x squared times x squared times x squared, right? 2 plus 2 is 4, 6, 8, right? So this can come out as an x squared in front of the radical. Then we'll deal with this number in a second. So this is going to equal -7x squared times the 4th root of 486. So that makes things a little bit easier. Or you could just think of that as x to the 8th all to the 1/4 power, and we would have ended up 8 divided by 4 is 2. So it works the same way. Now let's break this up. I'm not too sure about 46. Let's see if we can divide it by, let's divide it by 2 a bunch of times, see what happens. Let's see, so 46 divided by 2 is going to be 243. 243 times 2, and then 243. I wonder where that can, let's see, 437. Looks like it's divisible by 3. Let's see what happens there. Yeah, so it ends up being 81 times 3. Then 81 is 9 times 9, and then these end up being 3 times 3, and that's 3 times 3. So this is a fourth root, so we're looking for groups of 4. We have 1, 2, 3, 4 here. So we have a 3 that can come out to the front. And then we have a 3 and a 2 left, which are going to multiply inside the radical. So that 3 comes out, so we get negative 7 times 3, or negative 21 x squared. And then 3 times 2 is 6 inside the radical. So fourth root of 6. Number 11. We've got 6 times the fourth root. I guess fourth roots are popular these days. All the rage, kids love them. 243 times n to the 8th. Now I could just cheat up and look at this. Let me show the screen here. I could just cheat up and look at the last problem and realize that 243 breaks down into 3 times 3 times 3 times 3 times 3. And I think I might do that, actually. Let's see. So that just breaks down. So we have an n to the 8th. We already know that if we have an 8th power and a fourth root, we just divide the power by the root. So that's going to end up being an n squared that comes out. So that equals 6n squared times radical 243. It's the fourth root. Now 243 we already know breaks down into this. So let's just kind of break it down there. We have 3 times 3 times 3 times 3 times 3. And you can punch it into your calculator, you'll know. You'll end up with 243 if you do this multiplication there. And since it's the fourth root, we're looking for groups of 4. There's one. So that can come out outside the radical. And then we have a lone 3 remaining. So we get, see, 3 times 6 is 18. We have an n squared. And we have a lone 3 inside the radical. So it'll be 18 n squared times the fourth root of 3. Number 12. We have negative 7 times the fifth root, there we go, of 192x. Okay, we know we can't do anything with that x because it's being taken to a power less than 5, so that we have to leave alone. But 192 we can probably break down quite a bit. Let's see what we can do. Let's just start dividing by 2. So 192 divided by 2 is 96. So we have 96 times 2. And 96 divided by 2 ends up being 48. So 48 times 2 is 96. 48 divided by 2 is 24. Am I still in view here? Yep. 24 times 2. And then 24 is going to be, let's call it 8 times 3. And we know that 8 is 2 times 2 times 2. Okay. So we're doing with a fifth root. So we're looking for groups of 5. We have 1, 2, 3, 4, 5, 6 2s, so we could spare 1. Let's just use 5 of them here. And we have a 3 times 2 left inside the radical. So that 2 can come out. So 2 times negative 7 is negative 14 times the fifth root of, we have a 3 times 2 inside the radical, which is 6. And let's not forget about that x that we had there, so 6x. So we have negative 14 times the fifth root of 6x. All right, 4 more to go. And then you'll be acing these tests in no time. Well, looks like they're getting a lot more interesting.
Awesome. Okay.
Number 13.
How are we doing on time here?
Yeah, that should be too bad. We have 6 times the sixth root of 128 x to the fifth, y to the seventh. Okay, first thing I want to do, let's get that y out in front. So let's rewrite that as 6 times the sixth root of 128 x to the fifth, y to the sixth times y. Then we can just move that y out front. So that's going to equal 6y times the 6th root of all this business. 128 x to the 5th y. Sorry, I made that so small. All right, now let's start breaking down this this 128. I'll start here. All right, so 128, let's just start dividing by 2. Let's see what happens. 128 divided by 2 is 64. So that turns into 64 times 2. 64 divided by 2 is 32, so it'll be 32 times 2. Then we have 16 times 2. Then 8 times 2. We know 8 is 2 times 2 times 2. Awesome. Okay, so we already changed that to a y and brought that out, right? So since we have a 6th root, we're looking for groups of 6. 1, 2, 3, 4, 5, 6. So that 2, that can come out as a 2 in front, and then we have a lone 2 inside the radical. So let's deal with this right here. We know that 128 breaks down into this. So we have a 6y, and then this 2 can come out. So we have 6 times 2 is 12 y times the 6th root of, we have a lone 2 back inside the radical, so 2, and then we have an x to the 5th y inside the radical. Number 14. Let's see, we have negative 7 times the 5th root, getting more interesting, of negative 192 u squared v to the 5th. U squared v to the 5th. Okay, we know that we can't do anything with that u squared. Actually, first of all, let's deal with these negatives. Remember, if we have a negative inside of an odd root, that negative can just come out. So this will just be a positive 192. Well, negative 1 times 7 is just going to be a positive 7, so it kind of wipes it out, right? So that v can come out. So we're going to have 7v times the 5th root of 192 u squared. Now let's break down this 192. Let's just start dividing it by 2. 192 divided by 2 is 96. So it's the same as 96 times 2. 96 divided by 2 is 48. 48 divided by 2 is 24, so it'll be 24 times 2. 24 is 8 times 3, and then we know that 8 is 2 times 2 times 2. We have a 5th root, so we're looking for groups of 5. 1, 2, 3, 4, 5. We have 5 2's that we can pull out. And what's left is a 3 and a 2. Okay, so this will come out as a single 2 outside the radical. So we have 7 times 2 is 14v times the 5th root of, let's see, the u squared. So we have 3 times 2 is 6. And then we have a u squared left in the denominator, left in the radical. So there we go. Oh man, I'm going to have to use another piece of paper. That's a drag. I'll just go ahead then. Get plenty of 15. We have negative 2 times the 6th root of 384. They're the u's and v's again. So we have u to the 5th, v to the 6th. Okay, so we know that v can come right out. So let's start breaking down these numbers first. 384. Let's just start dividing it by 2 and see what happens. 384 divided by 2 is 192. We've done this one before. It goes into 96 times 2, 48 times 2, 24 times 2, 8 times 3, and 8 becomes 2 times 2 times 2. It's a 6th root, so we're looking for groups of 6. 1, 2, 3, 4, 5, 6. So we can take this business here, and what's left inside is going to be 3 times 2, and then that v to the 6th can come out too. So it ends up being outside the radical. We have negative 2 times 2, which is going to be negative 4. That v comes out, times the 6th root. Now what's left inside the radical is a u to the 5th, and we have a 3 times 2 is 6. So 6u to the 5th. Last one. Let's knock this out. We have number 16. Okay, we have the 6 times the 7th root. Hey, cool. Of 384. X to the 9th, y to the 8th. This mosquito bite on my hand is driving me nuts. Man. Okay. Okay, we already know the factorization of 384 because we just did it here, right? So I'll just take a little bit of a shortcut there. Right? We know it factors to 2 times 2 times 2 times 3 times 2 times 2 times 2 times 2. Right? So I'm just going to break that out completely here. So we have 2 times 2 times 2 times 3 times 2 times 2 times 2, right? 1, 2, 3, 4, 5, 6, 7 2s and 1 3. Okay. Now, let's see. So we're taking a 7th root. So we have 7 2s that can come out here, and there's a lone 3 left inside the radical. Now we're going to rewrite these. Let me just take these down here. X to the 9th, y to the 8th is the same as, let's see if we can get 7th powers going on. So it's going to be x to the 7th times x squared. That's the same as x to the 9th. And we're going to have y to the 7th times y. So we have an x to the 7th and a y to the 7th that can come out as well. And what's left is an x squared and a y. So let's take a look at what we've got. So what's coming out of the radical in terms of numbers is a 2. 2 times 6 is 12. We have an x and a y coming out. And what's left inside the radical is going to be an, let's do the numbers first. We're going to have a lone 3. We're going to have an x squared and a y left inside the radical. So we have 12xy times the 7th root of 3x squared y. And we're done.
Time to go watch Big Brother. Take care.